Hello guys, myself Vishnu Saraswat, and in today class we will discuss about the thermometry, thermal, thermal expansions, and calorimetry. So before we start the thermometry, thermometry, and we will discuss temperature. Okay, so as we know, what is temperature? Temperature is measure the degree of hotness and coldness of a body. Suppose we have a two body at different temperature, two bodies at different temperature 1 and 2. The first body, the temperature is at 100 degrees Celsius, and the second body at room temperature or 0 degrees Celsius. Okay, so we consider at 0 degrees Celsius, and the first body is at 100 degrees Celsius. So the natural flow of heat is higher temperature to lower temperature. Suppose we put both of these bodies together like this, so the temperature of the first body is going to reduce. That means the both the bodies come at the thermal equilibrium, or we can say at same temperature. The same temperature of the uh, both body at same temperature. The same temperature is called the thermal equilibrium. Thermal equilibrium. So the temperature of this whole system around 50 degrees Celsius, because we can calculate the average both of the bodies, like 100 degrees Celsius plus 0 degrees Celsius divided by 2 by using the average formula. So the body may be around 50 degrees Celsius approximate. So the bodies are said to be in thermal equilibrium when no heat flow from one body to another body. Suppose in the first case, we are talking about the 100 degrees Celsius. The first body is at 100 degrees Celsius. That means the heat flow from first body to second body. But when both the bodies at same temperature, there is no heat flow. That means if the whole system is at 50 degrees Celsius, there is no heat flow between both of the bodies. So, as we know, the temperature is the one of the fundamental quantities with the dimension of theta, and seven fundamental quantities as we discussed in the first unit. So, can you tell me the seven fundamental quantities in the comments? Okay, I will explain here the seven fundamental quantity. As we know that the length and the unit of length is meter, and mass, the second one, the unit is kilogram, time, unit is second, and current, ampere, unit, and again come to the temperature. Temperature is the unit of the temperature unit is Kelvin or degree Celsius, and SI unit is Kelvin. Okay, and then come to the luminous intensity. The unit of luminous intensity is candela, and quantity of substance, which is measured in mole. So these are the seven fundamental quantities, and temperature is one of the seven fundamental quantity. So here I again write it, all the seven fundamental quantities. So you will recall length, mass, mass, and time. Sorry, sorry. time, you can note down time, and the unit of length is meter, mass is kilogram, time is second, current current is in ampere, and temperature in Kelvin, and luminous intensity candela. Okay, so, and quantity of substance is mole. Okay, these are the seven fundamental quantities as already discussed in the first unit. Okay, so temperature is one of the seven fundamental quantities. Okay, and when heat is given to the body, when heat is given to the body, its state does not change. The temperature of the body is rises, and if heat is taken from a body, the temperature fall, and the temperature can regarding as a effect of cause like heat. So here what I am trying to deliver, that how the body changes the temperature when it absorbs the heat or release the heat. So keep in mind this point is very important to understand how this works. So according to the theory of kinetics, and the temperature is a macroscopic quantity, and it's measure the average translational kinetic energy of the molecule at microscopic level. And what is macroscopic and microscopic? I will explain. The macroscopic, which we can see with naked eye, macroscopic. And when we talk about microscopic, which we can't see with naked eye. So the microscopic, we use the microscopic cameras or other equipment to see the atoms, molecule at microscopic level or nanoscale. And when we go at a nano range, then we need a TEM device like a transmission electron scope microscope. And but when we talk about when we see that the cells, then we need a microscopic camera. And here the temperature is now come to our main topic, that thermometry. And in thermometry we will discuss here, first is temperature. So the temperature is a macroscopic phenomena. And but when we talk about the average translational kinetic energy is uh, of a that is molecule that is microscopic level. So these things keep in mind always. And now we can take some everyday example, like a cup of tea cools down to at the room temperature if left on a table or at your kitchen. When you touch the ice, heat flow from your hand to the ice, making your hand feel cold. Okay, so these are the some basic example to check the degree of hotness and coldness of a body. So this is all about the temperature. And as we discussed, the unit of temperature, SI unit is Kelvin, and everyday unit, common everyday unit is degree Celsius, and Fahrenheit. So in some cases, when we check the temperature of our body, and we always measure in the Fahrenheit. And some important reference temperatures, like a normal human body temperature is 37 degrees Celsius, but when we measure by the thermometer, so it always give the reading in Fahrenheit. So it around 98.6. and ice melt at 0 degrees Celsius and 273 yeah, when we convert into the Kelvin temperature, so it's 273 Kelvin, and the boiling water is 100 degrees Celsius. And when we talk about the hotness of the sun or sun surface, it's 600,000 Kelvin. The absolute zero is 0 degree Kelvin. So now come to the scale of the temperature. How many scales? So we can measure the temperature in different ways. So that basically in daily life we generally use three scales. So the scale of temperature, scale of temperature. The first one is Fahrenheit. Fahrenheit. The second one is Celsius, and third one is Kelvin. So these are the three basic scale of temperature we generally use in daily life. So the temperature, this is degree Fahrenheit, degree Celsius, and this is degree Kelvin. Okay. So to construct a scale of temperature, so two fixed point are taken. Two fixed point are taken. That means the first fixed point is a freezing point, ice point of water. It is called the lower fixed point. So in case of lower fixed point in Fahrenheit, it is 32 degrees Celsius. Suppose we took a reference line. So this is the freezing water, freezing water at 32 degree Fahrenheit, and in Celsius this is 0 degrees Fahrenheit, 0 degrees Celsius, and in Kelvin temperature 273 Kelvin. And the second fixed point, this is the first fixed point, and the second fixed point is boiling. So boiling water is 212 degree Fahrenheit, and in degree Celsius is 100 degree Celsius, as already know 373 the many of the student. But I'm trying to explain here everything. So in degree Fahrenheit, so we have a two fixed point. The one is the lower fixed point and another is the higher fixed point. So here what we are explaining now, the Celsius scale. The Celsius scale. So in the Celsius scale, the ice point is taken 0 degree Celsius, as I already told. Ice point is taken 0 degree Celsius, and this is the lower fixed point in temperature, and this is the second reference point, or we can say the steam point of water is taken 100 degrees Celsius. The temperature measured on this scale is in degree Celsius. So in this scale, you can write down in the Celsius scale. In this scale, the lower fixed point is 0 degrees Celsius, and the upper fixed point, or we can say the highest fixed point, is 100 degrees Celsius. But when we talk about the Kelvin scale, so in Kelvin temperature scale, also known as the thermodynamic scale, and note down the Kelvin temperature scale, temp Kelvin temperature scale. It's also known as thermodynamic scale. Thermodynamic scale. Okay, so the triple point of water is that the point on the PT gram where the three phases of water, liquid, and gas can coexist in equilibrium. Triple point of water is that point on the PT diagram where the three point of, or we can say three phases of water like solid, liquid, and gas can coexist together. So note it down. This point is very important. The triple point of water, triple point of water is that point on a PT मतलब pressure temperature diagram, pressure temperature diagram where the three phases of water, the solid, liquid, and the gas can coexist in equilibrium. Guys, keep attention on everything, because when we will discuss about the numerical section, and these all the basic point you need to know at that point, and if you don't know this point, then you can't calculate the numerical in your exam. So keep attention. So here we will discuss, and basically that we use already I told you we use the three scale of temperature in daily life, but we have another two scales of temperature like Rankine and Reaumur. So I can explain here in the form of table. Suppose this is the first row, and we can make some columns as well. Okay, so here we write down is scale. In the second is column is symbol for each degree. In the third column shows the lower fixed point, and third column shows the high or the upper fixed point, and last column shows the number of division on the scale. Number of division, number of division on the scale. So as we discuss Celsius first, Fahrenheit the second one, Fahrenheit, and you can also swap, because I already discussed the Fahrenheit first, the Celsius is second, and last one is Kelvin. But I have here I have discussed the first one is Celsius, Fahrenheit, then Reaumur, Reaumur, and Rankine, and the last one is Kelvin. So these are the five temperature scale which we have used. But in generally or in daily life, we use the Celsius, Fahrenheit, and Kelvin. And Celsius and Fahrenheit is very common, but uh, when we do some research or scientific things, we need to change the temperature, degree Celsius in Kelvin. So all the measure temperature in Kelvin. So because the SI unit of temperature is Kelvin, that's why we already, or we can say we generally use the temperature in Kelvin in our physics. But in our daily life, we use the temperature in Fahrenheit when we check the fever. So we always use the thermometer. So the thermometer, the scale is in Fahrenheit. So here is the symbol: degree Celsius, degree Fahrenheit, and degree Celsius, degree Fahrenheit, degree Reaumur, and Rankine RA, and Kelvin. Okay. So as I already told you, the lower fixed point in the Celsius scale is 0 degree Celsius, and upper fixed point is 100 degree Celsius. So the number of division on the Celsius scale is 100. How many? 100. In Fahrenheit scale, we use the lower fixed point is, or we can say the reference point is 32 degrees Fahrenheit, and upper fixed point is 212 degree Fahrenheit. So the number of division on the scale is 180. So, and now come to the Reaumur. The Reaumur is 0 degree, 0 degree R, and 80 upper fixed point. So the number of division is 80 on the scale. And now come to the fourth one is 460 Rankine, 460 Rankine, and low upper fixed point is 672 Rankine RA. So the number of division on this scale is 212. Now come to the last one is Kelvin scale. So the Kelvin scale, the lower fixed point is 273.15. It is a standard lower fixed point, and we generally took the 273, but its exact value is in magnitude is 273.15 and 373.15 in Kelvin is upper fixed point. So the number of division on this scale is 100. So, so by using this table, we also um, make the formula for if you don't know the, if you have a, suppose you have a degree Celsius temperature or degree Celsius scale, or we can say the Celsius scale or Fahrenheit scale, and you want to calculate the Reaumur scale and the Reaumur, the temperature in Reaumur, so you can also easily calculate by the help of the formula. So we write it down the, we will write it down here. The point is the temperature on one scale, temperature on one scale can be converted, can be converted into other scale by using the following measures, following measure or identity. Okay, suppose as I already shown in the table, the Celsius, we have a temperature scale: Celsius, Fahrenheit, Reaumur, Rankine, and Kelvin. Okay, as already discussed, the symbol degree Celsius, Celsius in degree Celsius, Fahrenheit is degree for F, and Reaumur in degree R, Rankine is degree RA, and Kelvin Kelvin. So the lower fixed point 0 degree Celsius of Celsius is scale, and 32 degree Fahrenheit is Fahrenheit scale, 0 degree and Reaumur scale, and 460 degree at Rankine, and 273.15 on Kelvin scale. So this is the lower reference point on the temperature different temperature scales, and upper fixed point are on the same scales, uh, like 100 degrees Celsius and Celsius scale. So you can see this table, and when you will forget, otherwise I think you will remember, and you need to remember, I think, otherwise you don't have any option. So the reading formula, I am writing down the formula how to calculate or how to convert one temperature scale to another temperature scale. So the reading on any scale, reading and on any scale minus lower fixed point, as I already discussed, and upper fixed point minus lower fixed point equal to constant for all scale, constant for all scales, ठीक है, right? So suppose you have a reference point of suppose you have a degree Celsius. So the degree Celsius, as we know, so we can write it down as C, and lower fixed point is on the temperature on the Celsius scale is 0, and upper fixed point is 100 minus lower fixed point of temperature Celsius scale is 0. So it is equal to 6 upon 100. Now come to this. You can also equivalent to this formula in Fahrenheit scale. So took uh, when we took Fahrenheit scale, the reading on any scale, that means this is Fahrenheit. We took Fahrenheit minus lower fixed point is 32 and upper fixed point is 212 minus 32, and again you can took another scale like Rumor or Kelvin. So the Rumor is R is the this one, reading on any scale is R. Okay, so you put here R minus lower fixed point of the Rumor scale is, you can see here, this is sorry 0 degree, so the 0, and again the upper fixed point is 80, so you put here the upper fixed point is 80 minus lower fixed point is 0, this one. So you can take 0, and now you can also equivalent to the Rankine scale or Kelvin scale. So in Kelvin scale we took K, reading on any scale means any scale. Right now we are taking Kelvin. So the Kelvin minus lower fixed point is 273.15 and upper fixed point is 373.15 minus 273.15. So again we equivalent to the Rankine scale in this formula. So the any scale, reading on any scale is Ra minus, so lower fixed point is 460 and upper fixed point of on the Rankine scale is 672. So 672 minus 460. So now these all the temperature scale is equivalent to the constant for all, or we can say the constant. Okay, so now you can convert uh, now you can convert any scale into the another scale. Suppose you have a temperature in degree Celsius, you can convert into the Fahrenheit, in Kelvin, Rankine, and Reaumur. As you know, as I already discussed the formula, reading on any scale minus lower fixed point, this is one, and lower fixed point and upper fixed point, minus lower fixed point equal to constant. In all cases, if you have temperature scale in degrees Celsius, you put C minus lower fixed point is 0, upper fixed point 100, lower fixed point is 0. And in case of Kelvin scale, you put here is Kelvin, lower fixed point 273.15, and upper fixed point is 373.15, and minus lower fixed point, and again you can do. So you will remember this scale, and this will help a lot in your exam, because sometimes they directly ask the, and they given to you some degree Celsius temperature given to a degree Celsius or in Fahrenheit, and can or they want to convert into the Reaumur or Rankine. So you can directly calculate by using this formula. So we can simplify this uh, formula like this: Cy5 and F minus 32 by 9 equal to K minus 273 upon 5 equal to R upon 4 equal to RA upon RA minus 460 upon 10.6. Actually, I directly wrote down this whole formula. You have to check it. If I did any mistake in this formula, I think I didn't do any mistake here, because I learned this formula. So here, this is the thing in how you can deal with the temperature, different temperature scales, or how you can uh, convert the temperature scale from degree Celsius to Fahrenheit, Fahrenheit to Rankine, Rankine to Reaumur, Reaumur to degree Celsius. So these all are interconnected, and you need to learn this formula. Keep in mind, you need to learn this formula. Okay, C by 5 F minus 32 divided by 9, and 9 and K minus 273 divided by 5 equal to R by 4, and RA minus 460 divided by 10.6. So you can calculate any temperature in any scale. So now come to the thermometry. As already discussed in the um, class, we will discuss about the thermometry. So thermometry is the branch of science which deals with the measurement of temperature of the substance, is known as thermometry. What is thermometry? Thermometry, the branch of science, or a branch of science, a branch of science, a branch of science which which deals with which deals with measurement of temperature. If I do any spelling mistake, and please, and sorry for that, actually, if I did any spelling mistake, so you will correct by yourself. Okay, so keep in mind, if I did any mistake in the word, like in a measurement, I think correct. Okay, everything, I think I am more focused, I am more focused to explain how the thing will happen in the thermometry or the temperature scales. Like I didn't explain the thermometry before, because I know if I didn't explain the temperature in terms of scales, you don't understand the thermometry directly. So that's why I discuss first temperature, then scale of temperature, and how we will measure, or how we measure the temperature on different scales like Kelvin, Reaumur, Rankine, and Fahrenheit. So that's why I discussed already the temperature. I think you have to learn that formula as I discussed, or that table as well. You have to learn, and they will definitely help you in your exam. So now come to again the thermometry. So the a branch of science which deals with the measurement of temperature of a substance is known as thermometry. And the linear, suppose uh, when we talk about the linear variation in some physical properties of a substance, and the temperature is basic principle of thermometry, and these properties are defined by the thermometric properties of the substance. Suppose the thermometric properties may be what, the length of the liquid in the capillary, pressure of the gas at constant volume. You can write it down, the thermometric properties of the substance. The first one, you can write it, the first point, the linear variation in some physical quantities. Linear variation in some physical properties is of a substance with change of temperature is the basic principle of thermometry. And these properties and these properties defined as thermometric properties. Thermometric properties of the substance. So here the first thermometric properties is length of the liquid, length of liquid in capillary. You can write capillary. The second is pressure of the gas, pressure of gas at constant volume. The third one is volume of the gas, volume of gas at constant pressure. And fourth one is the resistance of given platinum wire. So these are the, suppose, thermometric properties. Thermometric property. Okay, may as follow. So the first one is length of the capillary in the liquid. The second one is pressure of the gas at constant volume. Third one is volume of the gas at constant pressure. Fourth one is resistance of the given platinum wire. Okay, so these are the thermometric properties. which you need to keep in mind. And the other point is you have to take on in modern thermometry when uh, we took the two fixed point, only one is the reference point is chosen, like a triple point. The triple point of water is 273.16, and the other it is itself is 0 Kelvin. The thermometric properties is assumed to 0. So you have to calculate like in old thermometry, the freezing point is 0 degree Celsius, steam point is 100 degree Celsius are taken to define the temperature scale. So the temperature scale and thermometric properties and temperature scale. Okay, in you can rewrite it down this point because this is also important. In old thermometry, thermometry, in old thermometry, the freezing point is 0 degree Celsius and steam point steam point is 100 degree Celsius. You can write down steam point and this is freezing point are are taken to define the temperature scale. The temperature scale. So if the thermometric properties at 0 degree Celsius and 100 degree Celsius and T degree Celsius is respectively, suppose, so if the thermometric property at temperature 0 degree Celsius, 100 degree Celsius and T degree Celsius are x 0, x 100 and x. We can write is okay, x is T degree Celsius is x respectively respectively. Okay, so as I already told you the formula of the how we can uh, change the temperature scale from one temperature scale to another temperature scale. So here we use that formula. T is the temperature scale minus 0 is the reference point and upper reference point minus lower reference point and equal to x is the another scale which I need to mention or discuss here. 0 x is 0 temperature or the lower temperature, we can see the lower fixed temperature, and x 100 is upper fixed and x0 is 0. So you can write it down like this: T equal to x minus x naught upon x 100 minus x naught into 100 degrees Celsius. So this is the one standard, or we can say the old thermodynamics in old thermometry, as we discuss the temperature like this. So in modern thermometric, instead the two fixed point, okay, you can write it down again. The modern thermometry, in modern thermometry, instead of two fixed point, only one reference point is chosen. Only one reference. Uh, Actually, in old thermometry, what we are doing, We are choosing the freezing point, steam point, but in modern thermometry, we have just fixed one reference point, or is chosen to the triple point of the water. The water and other is itself is 0 degree Kelvin. So you can get the idea when you have to complete this. Okay, I think you are getting my point. Okay, in modern technology, instead of two fixed point, only one reference point is chosen. Reference point is chosen. You whose the triple point who sorry triple point of water, point of water 273.16 Kelvin. The other is itself 0 Kelvin, where sorry where I think you got it till now. In modern thermometry, instead of two fixed point, only the one reference point is chosen. The triple point of water is 273. The other is itself 0 degree Kelvin, where the value of thermodynamic properties is assumed to be zero. Where the values of thermodynamic properties, thermodynamic, thermometric, not thermodynamic, thermometric properties is assumed to be zero. Is assumed to be zero. Okay, so mm, the formula becomes now. So if the values of thermometric properties at 0 Kelvin, 273.16 Kelvin, and T Kelvin are 0, x, and x respectively. Okay, so T is the temperature scale and 273.16 is the one temperature, as I already triple point of water we consider, and x upon x is the triple point. This is the formula. X is the triple point, xtr, and x is we mention here. T is the reference scale temperature, and 100 is replaced by the triple point of water 273.16. So the formula becomes the 273.16 x upon xtr in Kelvin. So you need to remember this formula in the modern thermometry. So now come to the thermometers. Okay, so the thermometers is an instrument used to measure the temperature of body is called the thermometer. And many types of the thermometer available in the market: liquid thermometer, gas thermometer, resistance thermometer, and thermoelectric thermometers, pyrometers, vapor pressure temperature, sorry, thermometer, vapor pressure thermometers. So we will discuss in the thermometers these all the things. So thermometers, or we will stop here. We'll discuss in the next class. Okay, just we can discuss the surface level things, not discuss everything. So you will grab the idea. So the thermometer is the mainly our liquid thermometer. You can write it down: liquid thermometers, gas thermometer, and resistance thermometer, thermoelectric thermometers, and pyrometer, and vapor pressure thermometer. These are the 6 thermometers, and we will discuss in the later class. Okay, so till then, enjoy and keep learning.